The Doyle Rotary is a split-cycle rotary engine that utilizes 2 rows of pistons and cylinders. Each row of cylinders performs 1/2 of the 4-stroke cycle. The first row of cylinders pulls in and compresses fresh air. The second row of cylinders completes the power and exhaust strokes. The combustion cycle is completed 6 times per revolution. As the cylinder block and outer housing rotate, displacement occurs without any reciprocating mass. The cylinder block and outer housing rotate about the crankshaft on offset axes. This offset creates the stroke of the pistons. While using fewer moving parts, the Doyle Rotary completes the 4-stroke cycle in a smooth and continuous motion. More advantages can be revealed by dissecting the individual components. The stationary crankshaft is the heart of the Doyle Rotary. It contains the seals, ports, combustion chamber, spark plug, and fuel injector. The ports are separated by off-the-shelf seals from the 2011 Mazda RX-8. Dividing the ports with stationary seals has many advantages over conventional valve trains. Port timing is controlled by 58 parts instead of 200 or more valve train components. This leads to cheaper and easier assembly. Static seals are less prone to failures and completely safe from many of the catastrophic failures of conventional valve trains. Seals are a simpler and more reliable way to time the ports. Unlike valves, the ports open and close instantly. This increases the duration of the ports and the duration spent at peak flow rates. Because the cylinders share a single intake runner, at least 2 cylinders pull in air at all times. This means the air enters the engine in a smooth, uninterrupted flow. Combustion occurs in a central combustion chamber. After air is compressed into the chamber, fuel is injected and ignited. The mixture is allowed to burn within the chamber while the power piston moves into position. The Doyle Rotary achieves lower NOx emissions because pre-ignition and peak combustion temperatures are cooler. This is a result of the intake and compression strokes occurring in cooler cylinders and from firing after top dead center. Burning the fuel in a central combustion chamber allows for a longer burn duration. Burning fuel more completely results in lower hydrocarbon emissions. Combining the crankshaft and valve train into one component creates many advantages while also simplifying the system. The cylinder block and outer housing rotate about the crankshaft on plain oil film bearings, like the main bearings of conventional engines. Because the cylinder block and outer housing are radially symmetric, the engine is innately balanced and dead weight does not have to be added for balancing. The tight, nested arrangement of the cylinders conserves space and material. The space and material savings add up to an engine that is much smaller and lighter per unit of displacement than conventional engines. The Doyle Rotary can dramatically alter the internal combustion engine market while using manufacturing processes that exist today. Without adding complexity, the Doyle Rotary provides many advantages. For more information, visit doylerotary.com.